During this presentation, we have to talk about Liouville's theorem, which is an interesting topic in statistical mechanics. This theorem consists of two parts. First part talks about the density of phase points, whereas the second part concentrates on the volume of phase space. Now write on the first theorem. The rate of change of the density of phase points in phase space is 0. This is our first theorem. Mathematically we can write d rho by dt is equal to 0. You know the meaning of the term phase space? Actually it is a 6-dimensional space in which the particles' position and momentum are described. Then what do you mean by phase point? In phase space, each particle's position and momentum define one unique point and that point is called phase point. This is the definition for phase point. To specify phase point, we are using the symbol gamma. Gamma is a function of position and momentum. If the system is having a number of particles, gamma is a function of q1, q2, qn, p1, p2, pn. This is our phase point. Now the density of phase point. Density of phase point rho is a function of gamma comma t. So this is rho of qi comma pi comma t. Here I represents 1 to n. Suppose the system is having a number of particles, I varies from 1 to n. This is the density of phase point. Density of phase points. Even though the phase points are making their motion, at a particular time, in a particular region, the density of phase point is a constant. Suppose few number of phase points are making the displacement from one region to another region. At that particular region, the same amounts of phase points are migrating. Anyway, the total number of phase points at that particular point in that particular time is a constant. That is the meaning for the first theorem. The rate of change of the density of phase points in phase space is 0. This is similar to motion of a fluid. Suppose a fluid is moving in the constant rate. The density of fluid at a particular point is a constant. Now we have to prove this first theorem, and the theorem number 2 talks about volume of phase space. I will write the second theorem. Theorem number 2. The volume in phase space is conserved over time. This is the second theorem. D by dt of gamma of del of gamma is equal to 0. Here del gamma represents hypervolume. From this theorem we may point out that the phase space is neither subjected for compression nor expansion. That's the meaning for this theorem 2. It talks about the incompressibility of phase space. Now we have to prove these two things one by one. Now we will prove the first theorem. For that, we should consider the continuity equation of fluid dynamics. According to fluid dynamics, dou rho by dou t plus del dot rho into v equal to 0. This is a continuity equation available in fluid dynamics. Rho, the density of the fluid, v, the velocity of the fluid. Now we have to develop a new continuity equation for our Liouville's theorem. It is dou rho by dou t plus del of gamma rho into gamma dot, which is equal to 0. Say this is equation number 1. Here velocity is replaced by gamma dot. You know that gamma is a phase point, which is a function of qi comma pi, phase point. Then gamma dot is a function of qi dot comma pi dot. Now we have to expand this equation 1 for our required form. Dou rho by dou t summation over I dou by dou q I of rho into qi dot plus dou by dou pi of rho into pi dot equal to 0. This is a required continuity equation. See here, this operator is replaced by means of dou by dou qi and dou by dou pi. This is pi, not dot pi, simply pi. Here gamma dot is our velocity. We have expressed it in terms of qi dot and pi dot. Qi dot, pi dot. This is u, this is v. This is further expanded as dou rho by dou t summation over I rho into dou qi dot by dou qi plus qi dot dou rho by dou qi. First term is over. Now go to this plus rho into dou pi dot by dou pi plus pi dot dou rho by dou pi, which is equal to 0. This is equation number 3. Just we applied UV formula. Rho dou qi dot by dou qi, then qi dot into dou rho by dou qi plus rho into dou pi dot by dou pi plus pi dot into dou rho by dou pi, entire is equal to 0. Now I have to modify this equation 3 into a new form. Simple alignment we have to provide. See here, dou rho by dou p summation over I q I dot dou rho by dou qi plus, take this term, pi dot dou rho by dou pi plus rho into summation over I dou q I dot by dou qi plus this term dou pi dot by dou pi. The entire is equal to 0. Consider this is equation number 4. Just I have taken out rho outside. These two terms are combined here. Then this term is present here. Then this term is present here. Now I have to proceed further. We have to use our Hamilton's equations. According to Hamilton's equation, we have to write the values of qi dot and pi dot. According to Hamilton's equation, qi dot is equal to dou h by dou pi and pi dot equal to minus dou h by dou qi. Now we have to use this for this dou qi dot by dou qi, dou qi dot by dou qi, which is equal to dou by dou qi of, the value of qi dot is dou h divided by dou pi, which is equal to dou square h divided by dou qi into dou pi. In the same manner, dou pi dot divided by dou pi, which is equal to dou by dou pi of, the value of pi dot is minus dou h divided by dou qi, which is equal to minus of dou square h divided by dou pi into dou qi. See here, dou qi dot by dou qi is dou square h divided by dou qi dou pi, whereas the value of dou pi dot by dou pi is minus of dou square h divided by dou pi dou k. Instead of these two terms, if you substitute these two values, the third term of equation 4 is vanished. This is 0. Now we may modify equation 4 in the new form, that is given below. Without the third term, we have to present. Now, see here. Suppose the last term is vanished. Now we may write dou rho by dou t summation over I qi dot dou rho by dou qi plus pi dot dou rho by dou pi equal to 0. This is equation number 5. We know that rho, the density of phase points, rho is a function of qi, pi, comma t. Now we have to differentiate this with respect to time. d rho by dt, which is equal to dou rho divided by dou qi. Here we have to put summation over I into dqi by dt plus summation over I dou rho divided by dou pi into dpi by dt plus dou rho by dou t into dt by dt, that is 1. Say this is equation number 5. Now compare these two equations. Dou rho by dou t, here dou rho by dou t term is present. Summation over I. Now you have to develop this further. This is equation 6. Now you have to modify this further. See, dqi by dt is our qi dot. d rho by dt, which is equal to summation over I dou rho by dou qi. This is our qi dot. dqi by dt is qi dot plus summation over I dou rho by dou pi. This is our pi single dot plus dou rho by dou t. This is equation 7. Now compare the equations 5 and 7. We can get d rho by dt, which is equal to 0 automatically, because the value of d rho by dou rho by dou t plus qi dot dou rho by dou qi plus pi dot dou rho by dou pi is equal to 0. Here this value is 0. Now we may write from equations 5 and 7. From equations from equations 5 and 7, d rho by dt, which is equal to dou rho by dou t plus summation over I qi dot dou rho by dou qi plus pi dot dou rho by dou pi is equal to 0. This is equation number 8. Using 5 and 7, we have done this. d rho by dt is equal to this much. Actually, from equation 5, the value of right hand side of equation 7 is 0. From equation 8, we may write d rho by dt equal to 0. This is our first theorem. The rate of change of the density of phase points in phase space is 0. We have proved the first theorem. Now we will go to the second theorem. For that, consider the hypervolume. Let del of gamma be the hypervolume. The number of phase points in the hypervolume del gamma is n, that is equal to rho into del gamma. Rho be the density of phase points. We know that dn divided by dt which is equal to 0. Therefore, dn by dt which is equal to d by dt of the value of n is rho into del gamma which is equal to 0. Now we have to expand this. Say this is equation 9, this is equation 10. Now expand this equation 10. D by dt of rho into del gamma which is equal to rho into d by dt of del gamma plus del gamma into d rho by dt equal to 0. This is equation number 11. According to first theorem, according to theorem 1, d rho by dt is equal to 0. So this term is 0. Therefore, rho into d by dt of del gamma, therefore rho into d by dt of del gamma equal to 0. This is equation 12. Here rho not equal to 0. Therefore, d by dt of del gamma is equal to 0. This is our theorem 2. In this way, we have arrived Liouville's theorems 1 and 2. Thank you.